Hello, I'm Felipe Soriano. I'm a network solution architect with experience in designing wire and wireless network for various enterprise verticals. For this session, I will bring my design and security network access expertise to implement a zero trust network security framework.
I will be addressing the UMP and access row profile fundamentals to explain how the OmniSwitch and Stellar Wireless connected devices can be dynamically assigned to the authorized network resources. This is based on manually or dynamically enabled UMPs from the IL2 device fingerprinting cloud-based populated database in combination with access row profiles.
During the demo, I will walk through some of those workflows, which make it simpler, helps eliminate configuration errors by following and providing the required parameters to enable the device mobility, which leverages a unified access management architecture for the AOS on the wire side and for the Stellar Wireless devices, all provisioned through a single pane of management glass for the entire network. To set a better stage for the explanation of the UMP functionality and demonstration, I will first provide a high-level walkthrough of a typical hot end-to-end multi-tier network design populated with various OmniSwitch models and Stellar access points. This network design provides options for self-healing, self-provision capabilities under a high-performance SPD network overlay, or it could be a standard legacy VLAN network environment. In this section, I will provide an OmniVista overview for those of you who have not had experience with this network management tool. At this time, I will conduct a demo that I had delivered multiple times to customers and business partners that had visited us here in Calabasas pre-pandemic, of course. This demo will simulate a campus environment at a university using different user personas that have or don't have IoT device access based on their credentials for both wire and wireless network access. The purpose of this demo is to show that the same provision UMPs or access row profiles can be enforced for both the wire or wireless, and demonstrating a single unified management system to transparently configure and enforce the security profiles to authenticate and authorize all devices connected to the network.
Most people think security is a product or a set of features. My colleagues and myself have been advocating through our security-based presentation that security is a process. It's not just one product or a set of features that hardens one's network to become secure. It requires a framework from the people to the applications and onto the network, all working together to secure the IT infrastructure. I will now explain ALE's access row profiles reinforced through UMPs in the incorporation of the device fingerprinting and profiling techniques using OmniVista as the intelligence gatherer to dynamically apply security policies to the wire or wireless devices attaching through the OmniSwitch and Stellar Wireless access points. The security process includes services for authentication, privacy, by encrypting the data, which I presented in a previous session. I discussed the encrypting of network traffic from the end device through the ALE network via MACsec compliant networking hardware to help eliminate the man-in-the-middle attacks, as well as other possible denial of service attacks when unencrypted traffic could be captured by malicious actors. Security services include authentication and authorization to maintain the network integrity with timestamping and role-based device access control. All these security services play important roles in creating a secure networking environment. I will be explaining one of our newest security techniques to enable secure microsegmentation through the enablement of device fingerprinting via access row profiles helped by external third-party cloud-based database to help build a categorized inventory list of IP devices that connect to the ALE network through OmniSwitches and Stellar Wireless APs. Segmentation introduces new techniques for isolating parts of the network. Therefore, one problem in one part of the network does not impact other parts. Microsegmentation is a technique that allows to fragment the network into smaller segments. Those segments can be based on user, device, a service, a time of day, all controlled by ALE's unified access architecture. And this is made possible through OmniVista's access role profiles and user network profiles, which integrate with each other to provide the microsegmentation security features, which drives an OmniSwitch instead of wireless network. In the past, we have always called the network access control via user and universal network profiles, or simpler UNPs. In the following slides, I will be referring to this feature set as access role profiles which equals the user network profile applied to the devices that are fingerprinted and profiled on the IoT inventory list via an external cloud-based application and device signature database, which populates the OmniVista IoT inventory list with information from the database from the devices connecting to the OmniSwitch and Stellar APs. The access role profile contains information to microsegment both the wire and wireless network. The role-based policies provision in the UMPs will be leveraged by the access role profiles applied to the devices that connect to the network. The access role profiles can be defined by several parameters that include the VLAN tag, IoT profile policies, firewall rules, layer 7 application filtering, and even based on location and/or options for time of day parameters. For my demo later in the session, I have defined 3 personas that will authenticate through the same SSID, but the access role profile will contain different security access policies to allow or restrict the access to specific IoT devices. Let's first explain how this network-wide microsegmentation works transparently between OmniSwitch and Stellar Wireless while provisioned with OmniVista through its embedded set of tools, which includes an internal Radius server and the Unified Access Manager application, or simply known as UPAM. UPAM's AAA services can be used across an OmniSwitch and Stellar Wireless network. There are different ways to assign an access role profile to be assigned to UMP, such as 802.1x, through classification rules by default, radius change of authorization, or even manually. Here I'm illustrating the precedent of assignments on how access role profiles can be dynamically or manually assigned. The lowest precedent is the default via a pre-shared key or MAC authentication. The mid-level precedent is using an authentication strategy via 802.1x, MAC authentication, captive portal, or radius change of authorization protocol. And the most extensive one, the highest precedent, uses more extensive authentication parameters through the internal UPAM database or through external LDAP Active Directory or other external radius services such as EduROM for educational institution, hotspot, Wi-Fi upload, etc. The use of UPAM's internal database is a powerful tool as using external AAA services. It is up to the individual organization to reuse their existing AAA services or use the OmniVista integrated functionality for those services. ALE service-defined network architecture is powerful and flexible to accommodate the customer's choices. Some of these architecture workflows slides are borrowed from my peer Jorge Aranzaz, where he created a very detailed flow of the communication between an OmniSwitch and Stellar Wireless when applying a UMP to the wire side of the network and an access role profile to the wireless side via VLAN. In the next slide, we'll look at the option for using SPV services to automate the provisioning and enable of UMPs. In this VLAN mode case, let's follow the packet flow. The Stellar sends LLDP MED TVL frames during boot up. The LLDP frames are identified by the OmniSwitch's AOS and as it learns those MAC addresses associated with the stellar APs. For the OmniSwitch side, the UMP port profile must permit LDP frames in peer mode so AOS can capture the LDP frames and send them to its CPU for UMP authentication. The tags coming from the stellar AP need to be trusted. For example, in this workflow, VLAN 100 is dynamically created, and the VLAN 100 user traffic is tagged entering through the UMP port and placed in the right VLAN. When MVRP is enabled, that VLAN will be published to the MVRP domain. The UMP authentication profile can be provisioned for 802.1x, MAC authentication and classification rules to further help improve the security for the connected devices to the stellar APs and AOS Omni switches. This is the shortest path bridging solution for dynamic creating and provisioning UMPs over an SPV network. As seen in the previous slide, this also follows a similar process. For example, the UMP assignment level, the port is untagged and linked to the default WLAN access profile. It includes the management as ISID from the SPV side. For those of you who don't understand the SPV architecture and terminology, please refer to a newer documentation written by Patricio Martello. But for simplification purposes for this scenario, the ISID is the acronym for Instance Service Identifier, which is used on the SPV side and maps the VLAN idea from the legacy networking side. The user traffic is still tagged over VLAN 100, and here's where the classification rules are applied and dynamically mapped to the VLAN ID and to the appropriate ISID. Now, allow me to explain how this network-wide microsegmentation works transparently between Omni switches and Stellar Wireless while provisioned with OmniVista through its embedded setup tools, which includes an internal radius server in the Unified Policy Access Manager application, or simply known as UPAM. UPAM's AAA services can be used across an Omni switch and Stellar Wireless network. But for those customers that already have their own radius and or Active Directory services, UPAM can interoperate with those external servers. As illustrated in this application scenario, depending on the access policies and authentication strategy, either in the internal radius or the external radius or Active Directories, it will be used to return the access policies to the Omni switches and Stellar Wireless access points. For illustration purposes, in this case, the Stellar IP will receive a return policy from the external radius server number 1, server through the return policy number 3, as highlighted through these green shaded rectangles and red lines. The device's access request is received from the Stellar AP and then sent across the network, and depending on the matching radius attributes and conditions, it is assigned a specific authentication strategy that determines which radius or Active Directory server will be used for the AAA authentication. Now let's walk through this unified wire and wireless application scenario. In this case, I have a university's administrator with a wireless device using 802.1x supplicant enabled through its wireless NIC. That device connects through the Stellar Wireless AP. On the other side of the network, we have a wired device connected to the Omni switch. Both Stellar Wireless APs and the Omni switch know about the access role profile since they are transparently provisioned through OmniVista. OmniVista provides the device access to the appropriate VLANs, or in some cases, when it's going through across an SPV network, where ISIDs are used to enable containers for segmentation services, plus other security parameters that can be applied, such as access control list policies based on location and or time of day networking services. Following this network diagram sequence, when a device is dynamic associated to UMP, Its VLANs automatically tag so the network devices on its network path can forward the traffic across the network. As mentioned previously, the access role profile can include VLAN, ISIDs in the case of when using SPV for transport, plus other security options from layer 2 through layer 7. If this was an SPV network between Omni switches, then automatic ISID services will be created for the microsegmentation options, as indicated here on item number 2. There are different ways to assign access role profiles, such as 802.1x through classification rules, by default, radius change authorization, or even manually. Here I'm illustrating the precedence from the basic to the most advanced access role profiles assignment. The basic one will be via its default via pre-shared key or MAC authentication. And the most extensive with the highest precedence uses more extensive authentication parameters through the internal UPAM database or through external LDAP Active Directories or radio servers such as EduROM, Hotspot, Wi-Fi Overload, and among others. The use of UPAM's internal database is a powerful tool as using external 888 services. It's up to the individual organization to reuse their 888 services or use the OmniVista integrated functionality for those services. ALE's service-defined network architecture is powerful yet flexible to accommodate the customer's choice. The communications between OmniVista and the external cloud-based device fingerprinting database helps enable ALE's solution for allowing IoT devices to be securely onboarded for dynamic security network access. OmniVista dynamically assigns those categorized devices to appropriate network resources via access role profile. Here's a quick snapshot of my inventory list. It comes directly from OmniVista, and it will be used for my demo. It's actually live. If you notice the VLANs and UMPs I've been discussing, they're all listed on this snap capture. The status is reported in real time if the device is active or offline, the VLAN membership, and its final UMP where it was assigned based on the access role profile network security policies. This functionally works with the unified access architecture umbrella to enable access role-based policies. A UMP-defined network access, or in this case, it's manually or dynamically enabled through the enforcement of access role profiles for the categorized devices that are collected and fingerprinted as displayed in the active inventory list shown here. This new fingerprinting techniques and features helps network administrators use OmniVista to address the access issues associated with unplanned, unapproved IoT devices being connected to the corporate network. The network leverages OmniVista for user, device, and application profiling capabilities to automatically create and assign UMPs to each IoT and or a group of IoT devices. The enforcement capability of this feature has been supported starting with OmniVista release 4.5R01 through its unified access and IoT inventory application. In case I missed these details during my demo, here are some key reference fields and information that are specific to the dynamic created UMPs through their access role profile settings. To set the stage properly for my demonstration of the access role profiles via UMP solution, I will provide a typical campus network design where I will be explaining where the security policies are enforced at the network access through the OmniSwitch family of wire switches and through the Stellar wireless access points for both Wi-Fi and Wi-Fi 6 APs. The purpose of this slide is to set the stage to discuss the end-to-end network design scenario capabilities of the OmniSwitch and Stellar Wireless to position the secure device mobility by employing ALE's dynamic access role profiles for devices and user network profiles with authorized access to the network. But first, let's step through how I would recommend to design a multi-tier campus network the network access intelligence can be enabled at the access layer for both wire and wireless using dynamic provisioning based on the device profiling and fingerprinting. It is recommended for such multi-tier network design to be configured with redundant backbone connectivity from the wiring closets to the aggregation switches to or directly connected to the campus core, depending on the wiring infrastructure supported by the organization. The network should offer self-healing mechanisms to support high availability and optimal performance. High availability and performance can be accomplished through enabling a redundant backbone links and employing an SPV overlay network from the access switches through the data center core. The network core is designed as a virtual chassis of OmniSwitch 6900s or in a similar port count configuration depending on the end customer's philosophy of using a modular switch versus a fixed switch in the core. One can configure two OmniSwitch 9900s in a virtual chassis configuration of 2 units to support a similar functionality and performance for the network core. The network access is configured to support secure mobility and authentication via ALE's role-based network access features and enforced via the user network profiles. Here are specifics to the network access. Again, that this network view is to add context to the access role profiles and UMP architecture. To set the stage properly for my demonstration of the access role profile via UMP solution, I will provide a typical campus network design where I will be explaining where the security policies are enforced at the network access through the OmniSwitch family of wired switches and cellular access points, including the latest Wi-Fi 6 APs. My first persona, I will introduce the security officer. This security officer has network access to all the IoT security cameras around campus through the wired desktop terminals in the control center and through the wireless device when signed on with these credentials. The rest of the text is to set the stage when using a wireless tablet or a smartphone to connect to the security live feeds while roaming the campus. So please read that on your own time. Joe, the student, is another persona with its own UMP. He has access to the internet via the university's wireless network based on time of day parameters and access to the school's learning management system anytime based on his student's credentials. But he does not have access to the security camera feeds. The rest of the introduction he listed here is for you to make up your own story when delivering this type of demo. This is a reference testbed for the base of my UMP demonstration using the 2 previously described user personas. To show the flexibility of the UMP application, I decided to use the same SSID for the 3 different networks and UMPs to be applied to provide the micro-segmentation features.
At this time, I will conduct the demo. This demo will simulate a campus environment at a university using different user personas that have or don't have IoT device access based on their credentials for both wire and wireless network access. The purpose of this demo is to show that the same provision UMPs can be enforced for both the wire or wireless and demonstrating a single unified management system to transparently and enforce the security profiles to authenticate and authorize all devices connected to the network.
Let's begin the demo by showing what release of software I'm running here. It's OmniVista 0461. I'm showing here the switches that are already illustrated in one of the slides, but this is specific to their IP addresses and MACs. Then let me go to the IoT devices, just show that everything is offline. And then obviously my demo will enable them. There are different options to define the access role profiles, but here, let me do it through the workflows. As I mentioned plenty of times during the presentation, I'm selecting the 802.1x authentication. So I just set it there, or just enter my own. In this case, I'm OB Sierra Stellar. That's the SSID name. Actually, just the profile name. And there's the switches I can select. I can do one click and select them all or remove them all. In this case, I'm just selecting the two in my test bed here. And then AP groups, I have plenty of here. I'm hosting other people in my instance here. I just selected my APG. And then as far as the ports for the switches, a couple devices where I connect my devices that I can authenticate, making mobile ports. Here, it just picked up the same name as SSID. I'm increasing the security to WPA3. And regarding the authentication server, I can use an external server, as I mentioned earlier, or my UPAM. So since I define my user's UPAM, I'm selecting that, counting also UPAM. But here, I think this is the most flexible and strength. These are the ARPs that I've already signed. I can create new ones, but this is just the ones I've already defined. For the professors, the nurse, I treat them as faculty also. But the professor profile is assigned to VLAN 201. Nurse, I'll treat them as the same as 201, part of the faculty administration. For the security people, so I want them access to camera, I'm going to put on VLAN 200. And for students, on VLAN 202. And you'll see that as part of the UMP assignment and so forth later on. So this is where I've done that. I created this access role profile already, and I'm just assigning VLANs to them. I can assign other classification rules and other parameters, but this I already have created this, so let's go to them. Now I'm going to show you the defined access role profiles. I mentioned the security, the faculty, and the student. They all have their own parameters. See the policy list and black camera, so I'll show you the details of that. The policies are allow OTCP, UDP, and then the black cameras are the ones that I'm using for this particular demo. So let me show you the actual policy list. Policy list includes the specific one that I want to show. The power of it is the black camera. Basically created a policy here. If I want to allow students, I just remove that policy and the students will have access to the cameras. So here's the switch that I assigned them to and to the AP group. So I use my wizard to do this. Now let me show you for the black cameras, this is the policy actually created. This is where the container for all the security cameras are defined. I go through the policy creation, assign it to particular devices, Omni Switch and Stellar. And then this is where I assign the layer 3. IP group is the security cameras. This is where I define all the cameras are going to the container so they can be classified there. What I didn't show there was, here, the QoS, it's actually an action. Here it's the position drop. So anything coming to that container, access the container, drop it from the students. Not from faculty, not from professors, not from the security officers, but only from the students. This is, again, just a quick overview of what I've been explaining. Let me go over to UPAM, where I define my authentication strategy. I'm using the obseries.x strategy, and this is my employee accounts from the professor, student, security officer, myself, nurse 1, and other users that are defined throughout time for demos. Joe students at the bottom of the page here. And other professors, as you can see, they have their own access role profile and their policies list assigned to each of them, either open or to the black camera. Now it's time for actual users to connect to the SSIDs via their access role profiles and final assignment to UMPs. In this scenario, we have an iPhone from a student that a security guard knows the student wants to borrow the phone to check on a security account from the engineering building. So picks up the phone, just a regular iPhone, enters his credentials. Notice the SSID is OV0 Stellar, so same as the students, but in this case, the security officer is signing in with his credentials, hits the join button, waits, accepts the certificate that it issues, and goes in to check what address he's getting. Notice the subnet 200. He's happy. He goes over to the browser. This is a two-factor authentication for the camera. It's a good feature to have, not only authenticate to the network, but also to the camera. So I kept that enabled. He sees the security feed from the engineering building, goes around, puts it in, apologies for the landscape mode here, but it's a live feed coming through the camera. Go back to portrait mode. I can see it's still live. I can zoom in and check any trouble around the building. So the security guard sees that there's nothing happening, so he's happy. He still wants to do a physical check, but for now he's happy. Connects, checks, everything seems normal. So goes through and goes like a good security officer with following the standards, goes through and forgets the network, so he forgets all his credentials. Hands the phone back to the student, says, "Thank you, we'll see you. I know you're interning in our department, so I'll see you in 2 hours." So he leaves. The student is a little curious, says, "Yeah, I'm able to see the security feeds from the control center when I'm doing my intern hours. So I can do it through my phone. He just did it. So device dependent. I don't have his credentials, but let me try mine. Same SSID." So he goes, enter his credentials, joins the network, goes through a process. I go, I trust the certificate. Looks at the IP address. I'm in. Goes to the camera, refreshes it. Well, wait a second. The security officer already had a login for the camera. Obviously, I don't have that, but at least I can get it. But nothing connects. Go, let me refresh again. Nothing. Pay attention to the timestamp on top of the screen. It's 1:45. References later when I show you authentication records between the security officer and the student right after him trying to authenticate. So he sits there patiently. I go, come on, it could be a network problem. Tries it again. Goes, okay, well, let me see if I can ping the device. Since I'm already on the network, I have an IP address. He launches his ping app, types in the IP address of the camera. Because I'm a networking major, so I know my way around the network. Goes through, tries to ping the IP camera. Goes, was that the right IP address? He go and checks the security camera. Yeah, that's what the security officer used. Starts a ping. And obviously the security policy, remember layer 3, I applied to drop all packets from anybody with a profile as student. Cannot have access to that container. The student gives up and states, wow, this is a very secure network. And moves on, forgets the network so he won't get in trouble. As for what you just experienced with the security officer and the student trying to log into the same SSID, it was more on the security access policies that were assigned to drop all traffic from the student's profile as they access the security camera containers or IP group. Look at this authentication record timestamps on the screen that I just refreshed. The security officer, the third record on this list, he started his session at 1:42 p.m. and ended almost at 1:44 p.m. During those 2 minutes, he checked the camera mounted in the engineering building. When the security officer disconnected and handed the phone back to the student, then the student connected after his successful SSID authentication at almost 1:45 p.m. The student attempted to connect to the camera and ping it until he dropped at 1:47 p.m. This is a good resource to check the user and device activity through this authentication records or through the IoT inventory list that are referenced in my presentation with detailed information as to the status of the device, its network information, and the SSID join and the final UMP assignment. Do you recall earlier in this demo that all the devices on this inventory list were inactive? Well, now that I authenticated through different devices using different access role profile credentials, they are all active. And even though they are authenticated through the same SSID, they are assigned to different network segments, to different DHCP ranges, and different UMPs for security policies that are being enforced at the device level. And this is based on their login credentials.
Keep in mind that a zero trust strategy for securing the network is a process. A good start is to enable the UMP and access control profile architecture to manually or dynamically provision role-based security policies via OmniVista. ALE's digital age network strategy, powered by a service-defined network architecture that enables organizations to improve security and efficiency through dynamically configurable wire and wireless infrastructure that handles secure mobility